In this video, we're going to take a look at the quotient rule for square roots. So if the quotient rule for square roots says, let the square root of a and the square root of b be real numbers with b not equaling 0, then the square root of a divided by the square root of b is equal to the square root of a divided by b. Simplifying square roots containing variables, use the quotient rule to write as a single radical. Simplify the radicand using laws of exponents. If helpful, write the constant and prime factors. Remove perfect squares from the radicand, and simplify if necessary. In number 1, it says, simplify, assume all variables represent positive numbers. A is the square root of 162 x to the 11th divided by the square root of 2x to the 4th. And if we want to write this as a single radical, we can say that it's equal to the square root of 162 x to the 11th divided by 2x to the 4th. And now it wants us to simplify the radicand. And we have 162 divided by 2 is 81. So we have the square root of 81. And x to the 11th divided by x to the 4th is x to the 7th. And now it wants us to simplify the radical. So we can say that this is equal to the square root of 81 is 9. And we have the square root of x to the 7th. 7 divided by 2 is 3 with a remainder of 1. So we have x cubed and then the square root of x. In b, we have the square root of 24 times x squared y to the 5th, all raised to the cube, divided by the square root of 6x to the negative 3 y to the 9th. And the first thing it wants us to do is write it as a single radical. So we're going to say that this is equal to the square root of 24 x squared y to the 5th, both cubed, all divided by 6x to the negative 3 y to the 9th. Now it wants us to simplify the radicand. So we have the square root of, and the first thing that I want to simplify is everything in the parentheses in the numerator. So I have 24, and now I have x squared cubed, so that's x to the 6th. And then y to the 5th cubed is y to the 15th, all divided by 6x to the negative 3 y to the 9th. And that is equal to, now we have 24 divided by 6 is going to give us 4. So we have the square root of 4. X to the 6th divided by x to the negative 3 is x to the 9th. And y to the 15th divided by y to the 9th is y to the 6th. And now it wants us to simplify the radical. So we have the square root of 4 is equal to 2. The square root of x to the 9th, 9 divided by 2 is 4 with a remainder of 1. So we have x to the 4th. And then y to the 6th, 6 divided by 2 is 3, so y cubed, and then we had the one factor of x remaining inside the radical. Now it tells us, simplified form of a radical. A square root is in simplified form if it meets the following rules. The radicand does not contain any factors that are perfect squares. The radicand does not contain a fraction. And there are no radicals in the denominator. So for 2, the expressions below are not fully simplified. State the rule which the expression fails to meet, then simplify fully. Assume all variables represent positive numbers. So in A, we have the square root of 16 m to the 12th n cubed, and they say that's equal to 4 m to the 6th times the square root of n cubed. And this fails to meet rule 1, or number 1 in the box? Because we still have a perfect square inside of our radical. So we're going to rewrite this as 4m to the 6th. And now the square root of n cubed could be written as n times the square root of n. In B, we have the square root of 45 x to the 8th y cubed, all divided by x squared, is equal to 3x to the 4th y times the square root of 5y divided by x squared. And this fails to meet rule 2. We still have a fraction in our radicand. So we can say that this is equal to 3x to the 4th y. Now, the square root of x squared is x. So we have divided by x times the square root of 5y. And now we want to simplify. So we have x to the 4th in the numerator, x in the denominator, and that's equal to x cubed. So we have 3x cubed y times the square root of 5y. And that's our video on quotient rule for square roots.